Your AI agent isn't thinking, it's pattern matching at scale, and once you see how it works, you'll never look at AI the same way. In the next 8 minutes, we're breaking down exactly how AI agents work. No hype, no fear, just the mechanics. We'll cover what an agent actually is, how pattern matching replaces thinking, why memory is just a lookup table, how tools work, and the loop that makes it all go. An AI agent is just 3 things: a large language model, a set of tools, and a loop. That's it, 3 components, no magic, no consciousness, no digital brain pondering your questions. Let's break each one down, starting with the most misunderstood part. The language model is the brain, but it doesn't think. It generates text, 1 token at a time. Tokens are chunks of words, sometimes a whole word, sometimes half a word, sometimes just a syllable. The model takes your input, runs it through billions of parameters, and outputs the most statistically likely next token. Over and over, that's generation. Not reasoning, not understanding, just very sophisticated prediction. When you type "how are you," the model doesn't see 3 words. It sees tokens. How are you? Each token gets converted to a number, a vector. The model processes these numbers through its neural network and outputs another number. That number maps to the next token, then the next and the next. It's like dominoes falling, except each domino is a mathematical prediction. Here's what most people get wrong. The model doesn't understand your question. It doesn't know what understanding means. It predicts what tokens come next, based on patterns in billions of examples it's seen during training. Think of it like autocomplete on your phone, but scaled to trillions of tokens. It's autocomplete on steroids. When the pattern it's matching is well represented in training data, like writing a Python function, it looks genius. When the pattern is rare or novel, like debugging a weird edge case in your specific codebase, it hallucinates. It's not lying. It's just doing what it always does, predicting the next most likely token. Sometimes that prediction is wrong. A parrot can repeat "I love you" without feeling love. A language model can generate a perfect explanation of quantum physics without understanding quantum physics. Matching patterns is not the same as understanding meaning. This is the fundamental distinction most people miss. Remembers our conversation? Not really. What it is a context window, a fixed chunk of text that includes your messages so far. Think of it like a sticky note. Every time you send a message, it gets added to the note. The model reads the entire note, generates a response, and adds that response to the note. But the note has a size limit. When that window fills up, older messages get dropped. First in, first out. The model doesn't remember them anymore. They're gone. Some agents use something called retrieval augmented generation. That's a fancy way of saying, when the agent needs information, it searches a database of text chunks, grabs the most relevant ones and stuffs them into the prompt. Into that sticky note. It's a lookup table with extra steps. The agent doesn't remember anything, it just has a really good search function. Retrieval augmented generation is only as good as your search. If the search returns wrong chunks, the agent will confidently use wrong information. It doesn't know the difference. It can't verify. It just uses whatever text got stuffed into its context window. So when you hear AI memory, think lookup table, not hippocampus. Think search engine, not recollection. Now let's talk about tools. This is where agents get interesting. Search the web, run code, call APIs, read files, write files, send emails, book flights. The agent doesn't do these things itself. It generates a request and a separate system executes it. The agent generates a structured request, like a function call. The runtime runs the search, gets results, and feeds them back. The agent never touches the internet. It never runs code directly. It just generates the right shaped request. Someone else does the actual work. Think of it like a movie director. The director doesn't hold the camera. The director doesn't act in the scenes. The director gives instructions and 100 skilled professionals execute them. The agent is the director. The tools are the crew. The agent isn't powerful, the tools are powerful. The agent is just a really good director. This is where it gets interesting. The agent runs in a loop: observe, think, act. First it observes, reads the current state. Then it thinks, generates the next step. Then it acts, calls a tool, or produces output. Then it loops back. Observe, think, act over and over. That's the reasoning plus acting pattern. It looks like reasoning. It feels like reasoning. But it's just the language model generating 1 token at a time, checking if it's done and repeating. If step 3 goes wrong, steps 4 through 10 build on that wrong foundation. The agent can't look back and say, wait, that was a mistake. It can only work with what's in its current context window. Error propagation is a real problem. This is why agents fail in predictable ways. Claude writes code by predicting. Given this function signature, what code follows? ChatGPT answers by predicting. Given this question, what answer follows? When an AI agent books your flight, it's generating tool calls in sequence. Search flights, check prices, select seat, confirm booking. Each step is pattern matching. The magic is in how many patterns it can match, not in understanding. When you understand how agents work, you stop treating them like magic and start using them like tools. You learn to write better prompts because you're feeding better patterns. You learn to design better workflows because you understand the loop. And you stop being scared of AI taking your job because you see it for what it is, a very powerful pattern matcher that still needs you to tell it what patterns to match. If this changed how you think about AI agents, hit subscribe. Next week, we're breaking down why 95% of developers get prompt engineering wrong and the one pattern that actually works. See you then.